In the last class, we discussed some of the basic concepts about the Unix. In today's class, we'll discuss the extended version of the Unix concepts. First, different flavors of Unix. Nothing but what are the different naming conventions has been used by the different companies here. Say for example, IBM is having the naming convention AIX, HP is having the HPUX, Sun Microsystem is having the Solaris, Red Hat is having the convention is Linux. This way they are having the different variants of the Unix operating system. Next, the most important part, that is the Unix system architecture. Again, find there is a specific diagram with respect to the Unix system architecture. Usually we can call as a kernel shell relationship. In this diagram, there is a three important concepts. One is hardware, second one is kernel, and third one is shell. That is the inner part, what we can call as a hardware, and next kernel, then shell. We'll discuss one by one. First, hardware. What do you mean by hardware or physical device? The hardware layer of the Unix OS controls the use of physical system resources such as memory management, processor manager, disk drivers, devices, and so on. Hardware consists of all the peripheral devices like RAM, hard disk, CPU, and so on. I hope you got the point here. Hardware is nothing but it is different devices what we are using as part of the system. Next, the more important part of the system architecture, that is kernel. Kernel is core part of the Unix operating system, or sometimes we can call as the heart of the Unix operating system. What it will do usually, it is act as an interface between hardware and shell layer. Here the term interface, nothing but it will act as a bridge between a hardware and a shell layer. We discuss shortly what do you mean by shell. Already we discussed this hardware, what do you mean by hardware here. The most of the tasks such as memory management, task scheduling, file management, and so on are performed by the kernel on behalf of the user. That means allocation of the memories, deallocation of the memory, creation of the space for the programs, execution of a particular task, and making the scheduling of those tasks, then creating the files, removing the files, opening the files, reading the contents of the files. Like these activities will be managed by the kernel on behalf of the user. It manages the external commands in the Unix. Means the kernel manages external commands, means whatever the commands entered by the user, those commands are managed by the kernel here. Next, one more important component of the Unix system architecture is shell. Shell is an interface between a user application and kernel. That is nothing but, as we seen in the previous part, kernel is an interface between shell and hardware. That way, shell is an interface between user and kernel. Means, what are the commands entered by the user in the command prompt? It will be interpreted by the shell. The same thing is forwarded to the kernel in kernel readable form. That means, usually the user is entering the commands in Unix language. in English language. So those things are not understood by directly kernel. So the shell will interpret those things in kernel readable form. This layer, the shell layer is having the different processes. When we type a command at a terminal, the shell interprets the command and calls the corresponding program, which means, say for example, there is a one command called ln command, that is nothing but will link the files, means we are creating the hard links here, or it might be a symbolic links by using some options. Or one of the best example you can call as a date command. As we know that as the name indicate date, it will display the current date and time. So whenever we are executing that command, the corresponding program will be fetched from the system and execute on behalf of the user. This shell is using the standard syntax for all the commands. Means some commands can be executed directly, some command can be executed with options, some commands are executed with the command arguments. So these are the different syntax we are using with respect to different commands. Different shells are available as part of the Unix operating system, like some of the shells, C shell we can call as a CHH, Borne shell we can call as a SH, Corn shell we can call as a KSH, and Borne shell we can call as a Bash shell. So these are the different shells we are using in different versions of the Unix operating systems. These shells are located in one of the path name, that is etc shells, means it is a path name or directory, what we can say that. Under this directory we can find a specific shell of that particular Unix operating system. The shell is also managing the application programs, utility programs on behalf of the user. The data in Unix are organized into files, means whatever the content we wanted to store in an Unix, that will be stored in the form of files. Then what exactly the files? Files are a sequence of blocks. Usually these files is having a tree like structure, that is what we can call as a file system. Okay. And one more concept along with the file is process. Process is nothing but a program under execution. Whenever, as we taken the previously, there is a one concept called whenever we wanted to execute the specific command, so the corresponding program will be called. Again the program will be in the form of file only, but when it start executing, then we can call as a program. Again in turn we can call as a process here. With respect to the file system, we are having the different blocks. One is boot block, that nothing but it contains the boot scrap code that is required to boot the system, such as restart, shutdown, log off, and so on. So whenever we start the system, whenever we shut down the system, whenever we log off the system, so this boot block is playing an important role. Usually it is the beginning of the Unix file system. First sector, we can say that. Next, super block. It contains administrative information about the entire Unix file system. For example, state of the file system, free data block, number of inodes, number of disk blocks, next available free blocks, and so on. administrative information. Maybe you have one confusion here. What do you mean by administrative information? Which means that it is a core information required for the system to run other applications. So such information will be stored in the form of administrative information. Again, that will be storing in the file system only. And how we are accessing this one? That is by using the one concept called inodes. Inodes are nothing but they are providing the indexing for the file system. Next, just we can find there is one more word here, inode block. It stores the list about operating system inodes for all the files in this file system. Means whatever the file is exist in an Unix system, that is accessed through inode here. Okay. And one more concept we are having, the data block. That is nothing but all the files and administrative data are stored here. We can call as a metadata here. This concept usually we can call as a metadata. Next, there is one more concept called system calls. All the commands in the Unix system use a handful of the functions. That concept what we can call as a system calls here. So the remaining things will be discussed in the next video. Thank you.